Automation using Windows PowerShell 2.0. I'm Jeffrey Snover, Distinguished Engineer and Lead Architect for Windows Server.
I'm Dan Harmon. I'm a Senior Program Manager in the Windows Management Team at Microsoft.
Hey. Right, so this is a 400 level session. This is the advanced talk. So if you have not used PowerShell before, you're not going to be a happy camper, right? Okay. If you don't know how to use a for loop yet, probably the wrong session for you. So we should have some fun with this, but it is an advanced topic. The goal here is to learn about some of the improvements that we made in version 2.0. Made a ton of stuff there. Want to go into some of the more detailed advanced functions of that. Teach you how to use some of those things. You'll see that there's just so much there, we really can't fully cover it. And so what we want to do is to give you an overview of the things that are there, and then grab a few topics and go deep into them. And then also give you a conceptual way to how to think about what we've done in version 2. So what we're going to do is to go over an overview of the features, give you some detailed advanced scripting techniques, go over them in depth. We'll have a GUI over PowerShell demo. By the way, here's a note, and you might want to get your pens and write this one down. If you decide to pour water on your laptop, don't do it right before a demo. Okay, that's just like really, really important to know. You might want to just write that one down. So you notice we have one laptop here versus two. We have what used to be a laptop and is now a brick that has half of our demos on it. And so we've been frantically trying to recreate that second half here. Might work, might not. It'll be drama for us all. We'll see. I'm optimistic. And then we'll do some production demo script, and then talk about this universal code automation, universal automation environment demo as well. So PowerShell version 2. Oh my Lord, we put a ton of stuff into PowerShell version 2. I mean, just look at this list. We have a lead program manager called Kenneth Hansen. One of his statements was, PowerShell version 2 first needs to be a better PowerShell version 1, and then we're going to go add a bunch of features to it. So if you've used, by the way, let me get a feel for the audience. How many of you have been using PowerShell? Great. Just double check. Remember, if you didn't raise your hand, you're probably in the wrong session. So if you use PowerShell version 1, you saw, hey, it was great stuff, but it was missing a lot of things, and some of the things that were implemented didn't quite meet. For example, the way our WMI worked and the way some of our ADSI worked. We made that a lot better in version 2, and then we added just a ton of features. Here's the way you should think about this, okay? So this is what I like to call the big animal picture of PowerShell, okay? So you've got on the right hand here, all the managed elements, the stuff that actually goes out and does something, manage your environment, right? And so we have these things called commandlets. Commandlets are high-level task-oriented abstractions, and that's ultimately where you want to operate at. But it's going to take a long time before we get there, before everything has full commandlet coverage, right? I like to say we're digging our way out of a 30-year hole, okay? That's going to take a while before we complete that. Making great progress, but it'll take a while. So if you don't have a high-level task-oriented abstraction, then, and you still need to get your job done, then you might need to go deal with lower-level stuff. You might need to deal with WMI or COM or .NET or XML or ADO or blah, 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 all that stuff. But ultimately, we want things in commandlets. Then in the middle, we have engines, which is to say, hey, we'll go out and get this stuff, and then we operate on it. Okay, so we've got APIs for developers, this thing called an execution context, and an object manager. Once we get an object in, you find that objects are very different. An ADO object is very different than a database object. It's very different than a WMI object, all in ways that none of you care about. And so what we do is we mask all those differences. If you want the details, you can get them. But in general, most people don't want them. Boy, that's the other thing that'll help me. How many of you, I'm going to ask IT pro versus developer. How many of you consider yourself developers? Okay, and then IT pros? Yeah, okay, great. So this is largely dominated to IT pros. So we'll talk about the developer stuff, but really we're going to focus this in on the IT pros. And then on top of this, we have a user experience. And by the way, let me point out here, a lot of people think that PowerShell is a command line interface. They are wrong. PowerShell is not a command line interface. PowerShell has a command line interface. PowerShell is in fact an automation engine. Okay? That automation engine exposes a set of APIs that can be used by lots of different things, and one of them is the PowerShell.exe, which is a command line interface. Other things that use it are like System Center Virtual Machine Manager, entire rich graphical user interface built on top of the PowerShell automation engine. Okay? So it's an automation engine that has a command line interface. So too, it has a language and a debugger. So this is the way I want you to think about things as we talk about the features. Then for PowerShell version 2, we had these themes, okay? So we said, oh, what are all the things we could do? And there's a gazillion of them. And they said, okay, but what is it that we're going to try and accomplish in this release? And there were 4 things. First is GUI over PowerShell, right? Our destiny is to rewrite all the administrative GUIs in the world to be layered on top of PowerShell, okay? We did that in version 1. We found, Exchange did that, SCVVM did that. We talked to those folks, found some of the difficulties, and then addressed them in version 2. And then we also want to be able to allow you, the IT pros, to be able to do GUIs on top of PowerShell as well. And if the demo gods are with us, you'll see that. Production scripting, right? In general, everybody in this room is getting paid to do what they do. And when you get paid to do what you do, obviously people like it to work. And they like it to always work, and they like it to work in a way that makes them think, I got some good money for the money I paid for this. I get some good value for it. So these things that say, scripts that say work when they work and when they don't, say things like triple panic abort. You Unix guys will know what that means. That doesn't cut it, right? You want a production-oriented environment. We have this universal automation environment. We'll just hold that, put a placeholder there. It's hard to explain until you really get into it. And then the language and commandlets themselves.
All right, so GUI over PowerShell. Let's cover this first. So one of the key design tenets that we have when we talk about designing management tools is that you should layer your admin GUIs over PowerShell. And this gives a number of benefits. First of all, it drives consistency between the command line and the GUI. So typically you're going to write your commandlet layer first, which encapsulates your business logic. As part of that process, you're going to choose the nouns that go along with those commandlets. And those are the objects that you're trying to manage. And then you go and you choose your verbs for the commandlets. And those should get surfaced in the GUI as the things that you're trying to manage and the actions that you can perform on those managed things. So then when somebody's using the GUI, they can easily go to the command line or vice versa, and they have a consistent experience both ways. The second thing is it enables agility in delivering new GUIs. As I mentioned, you want to capture your business logic at the command line level, which makes it really easy to then build a GUI on top of that. And GUI developers love this because then they can focus on the GUI aspect and making it look really nice and making it really snappy and performant as opposed to trying to figure out what the business logic is. It's also much, much faster that way. And then third of all, it guarantees that anything you can do in the GUI, you can also do to the command line because you've forced this layering of GUI over PowerShell.
Yeah, there's a great story about that. The SCVVM guys, Virtual Machine Manager guys, the previous project that they had done, they were just super hardcore. The business logic here, the GUIs there, and they're separate, right? So that you can layer different GUIs on top of it. And they said, we're so hardcore on that, but then it dissolved on first contact with reality, right? Programmers were putting business logic up in their GUI code, they were putting GUI code down in their business logic. It was just a mess. So then when they went and did PowerShell, layered everything on top of PowerShell with SCVVM, they enforced this layer. And originally, SCVVM was written on MMC. And then the word came on down, no, don't write it into MMC, write it on top of the System Center GUI framework. And they said that they were able to transform that, just lift it up and move it over in a matter of a couple days. And they said, wow, we never thought that would be possible, but in fact it was. And that's because of this layering. It enforced the layering.
Right, right. Also, the layering makes it much easier. If you want to, you can expose exactly what the GUI is doing at the commandlet level. So then you can show the users as they click around and interact with the GUI, you can show them the commandlets that are being called underneath to accomplish those tasks. And in fact, in some cases, you can export a script, and that way, the GUI, when you interact with it, actually starts to teach users how to use the command line. And then, of course, because the GUI is going through the command line to access the managed elements, you have a standardized way to manage those managed elements.
Yeah, we're getting increasingly hardcore against local GUIs on servers. In fact, one of the things we're going to be coming out and saying is, hey, get your GUIs off our servers, right? They're just a bad idea. Whenever you have a local GUI on a server, it almost invariably is calling private APIs instead of public management APIs. And what that really means is that you can't remotely manage the device. And if you can't remotely manage the device, it means you can't automate it and you can't manage lots of devices. So we view local GUIs running on servers as evil from that perspective. Additionally, we see the future of GUIs as rich, multi-touch, blah, 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 consuming all available transistors to provide the best user experience. But you don't want to be consuming server transistors to provide that user experience. You want the server to do the server workload. So you will hear this, that's going to be a theme that we become increasingly strident about.
Right.
Or hardcore about.
So then when you look at how the GUI over PowerShell features map to our architecture, in the user experience area, we have our PowerShell ISC, our integrated scripting environment, where you can author and run scripts. We have our out grid view tool, which is a GUI tool that outputs to a grid control. And then in the engine area, we have a whole new API. We call it the PowerShell API, where you can create a PowerShell pipeline, add commands, invoke it, etc. We have some nice things that are really great for GUIs, like session pooling. You can create a collection of sessions or run spaces, and then PowerShell will dynamically manage that for you. And then much more control over threading, which is really important for GUIs, having control over the threading.
Yeah, and as a general rule, UIT pros, the middle column, don't worry too much about that. That's really for the developer audience.
All right, with that, let's switch over to a demo.
Cross your fingers.
All right, I want to show creating a GUI over PowerShell. I'm going to use the Primal Forms tool, IDE, from Sapien. There's lots of different tools that do similar things from our partner ISVs. This is the one we're showing in this demo.
And this is a scenario where IT pros will create tools.
Exactly.
Yeah.
Yep. So I just created a new form here, and I'm going to go and make it a little bit bigger here. And I can just use this library here to drag and drop controls onto the form. Drag a couple buttons here. And I can give these names. So for example, if I want to get processes, I say process. The process is here. And I can change the text size. Resize that a little bit here. And button 2, let's say services here. Adjust the text size. All right, and then maybe I can add a text box where I can input which services or which processes I want to get.
Is it a text box or list view?
This is a text box.
Should it be a text box or a list view?
It could be either one.
Your call.
And I can, let's see, give it a name here. I can put some default text in here, star, for example.
Oh, there it is, multi-line.
Yes, let's go multi-line true.
That's what it is. Yep.
Okay. And yeah, let's add another one for our output.
Oh, thought that was output.
And that one we definitely want to have multi-line.
I see.
So we can name this output, for example. We can expand that, take up more of our form here. And then we can choose this export to PowerShell. We can export it to a file. Stick this in our temp directory. My GUI 2. All right, now if we go back into our integrated scripting environment, our ISC, we can open that up and take a look at it. So this is the script that was generated by Primal Forms.
No, this one to maximize the script. Yeah.
And we can go through and we can edit this by hand. We can add click handlers for the different buttons and things. This runs. So here's our GUI. Right now, it doesn't do anything. You press the buttons. You can see I haven't wired up anything. I'm going to switch to one that I've already created to show you. This script is very similar. And let me go to our event handlers. So all I've done is, with one of the buttons, I've added a click handler here, and I'm just going to show some processes in this case. Let's find another one. Here I'm going to show some services. And here I'm going to show some processes as well. So I'm going to go ahead and run that. Again, a simple form. I can get all the processes, get a specific set, A star. Same thing with services. Get my top 10 processes. So you can see it's really easy to create, using one of these tools, create a simple WinForms GUI, add some scripts that you've already created perhaps, and wire them up to the event handlers for the different controls, and easily output the output. So you can make it so that somebody who is not familiar with PowerShell be able to use common tasks, and you have the opportunity to create those GUIs.
Yeah, the real point of this is, the phenomenon of scripting is often about somebody at one skill level producing something to be a tool to be used by somebody at a different skill level. A bunch of you here are advanced PowerShell users, so none of this frightens you, right? Oh yeah, I love it, love it. You might prefer somebody gives you a tool. But a lot of the tools you're going to generate are for people above you who don't have the skills or have skills in a different area, and they just want GUIs. So often the best way to give them what they need is for you to develop a GUI for them. And here's a simple way to do it. It's actually pretty straightforward to do.
Great, thank you. So I'll switch back over to the slides. Turn it back over to Jeffrey.
Great.
To talk about production scripting.
Yeah, so production scripting. Again, I mentioned that production scripting, a lot of this is about, in version 1, you could write scripts, okay, but it's hard to write production scripts, which is to say scripts that really, really matter. The sort of script that when everything's gone wrong on your production server and it's 2 o'clock in the morning, you want to be able to open up that script and see what it does and understand it and just have a sense of surety about things. And so what we want is, we want scripts that are easy to use, easy to share, easy to support, and easy to operate. And our vision here is that there's a sliding scale of formality, right? You all know, Bruce Payette has this great phrase. Bruce is one of the designers of the PowerShell language. And he has this great phrase. He says that the life cycle of 99% of PowerShell scripts begin with the command prompt and end with the carriage return, okay, which is to say an interactive environment. So then, if you find that you do something over and over again, you want to have an informal script. You're just going to use it yourself. I have a ton of scripts called T, because it turns out T is very easy to type, just T, T, T. And then when you say, well, no, I'm going to use it a little bit more frequently, you make it a bit more formal. When I'm going to share it to someone, I make it even more formal. And if I'm going to use it in a production environment or publish to the world, you want it to be even more formal. And so you see we have this sliding scale. So how does that translate in terms of a set of features? So the first are this notion of advanced functions. In PowerShell version 1, you could write commandlets in .NET, but in PowerShell you can only write scripts. Now, with these advanced functions in version 2, you can write commandlets in .NET or in PowerShell itself. Additionally, we have now native code. Native code. Why do we have native code? What that says is, in your PowerShell script, you can invoke C# or VB.NET to do pinvoke and access any Win32 API. Why? Because there are some Win32 APIs which are not exposed in managed code. Now, has anybody used this? Yeah? It's pretty chewy stuff. But when your option is failure, pretty chewy stuff, you go do it. And so what you do is you go to a place called pinvoke.net, and you just copy and paste the code that they give you there into PowerShell, and now you're able to access those APIs via PowerShell. We enhance the debugger. We have something called a restricted language, which basically is a safer subset of the language so that you can exchange data to one another. We sometimes call this the data language. We have modules, which is a way to encapsulate sets of PowerShell functions together and transport and share them with people. And then we also support transactions. Yes, true transactions. I think this is the only interactive shell that we know of that actually supports transactions, where you can say start transaction, perform a set of operations using a -use transaction switch, and then when you're done, either commit the transaction or unroll the transaction. Right now, we only have commandlets to do that for the registry, but we anticipate this will grow over the course of time. We'll see more and more of that.
So one thing I want to call out really quick, go back to that slide, is the level of investment that we made in production scripting is just huge in PowerShell 2.0. I mean, PowerShell 1.0 was great, but if you look at 2.0, it's just much more production ready, and that's reflective of the investment that we've made in production scripting features. I think we have a lot more here that we couldn't even fit on the slide. So
it's true. Yep. It's true. Now, the point about this is sometimes you might hear production scripting, scary, hard, scary, hard. No, 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 no. You'll see that it's a set of incremental things that you can optionally do. Each incremental step gives you more and more formality, more and more production qualities, and I'll demonstrate that. So the idea here is that you can write these commandlets using script instead of compiled code, and the benefit is gives you the consistent syntax and semantics between functions and commandlets, and it gives you near parity. There are a couple things that you still need to do in .NET, but really they're at the edge now. The bulk of you should be able to do the bulk of the things you want to do in PowerShell itself. And so you see here we now support commandlet attributes like should process. Should process is the thing that is behind the commandlets that support -whatif, -confirm, and -verbose. Have you noticed that those things always go together? The reason why they go together, it's a clever little piece of programming. What you do, and I'll show it to you, when you're about to perform an action that has a side effect on the system, you call should process, and you tell us what you're going to do to what. And that returns a Boolean, true or false. If it's true, you do it. If it's false, you don't do it. Okay? So when somebody says, oh, stop this process, they'll say, okay, I'm about to stop process LSASS. Should I do it or not? And then the engine takes a look at that and says, hey, if the user has specified -whatif, we form a message saying, here's what would have happened, and tell you don't do it, and it doesn't do it. If you say -verbose, we print a message saying what to do, and then we tell you to do it. And if you say -confirm, then we tell the user this is what would happen should they do it or should they not. And depending on whether they say yes or no, we return true or false, and the commandlet does it or doesn't do it. So it's a very small increment of investment on your part to deliver a huge benefit to your customers. We also have, so that's what this PS commandlet is. This PS commandlet here is what shows, has the function should process and should continue. We support external or internal help, and then we support these parameter attributes. There's just a ton of attributes where you tell us what the constraints on the parameters are, and then we do the validation. Okay, so this is better shown than talked about.
While Jeffrey's pulling that up, one of the key differences between advanced functions and compiled commandlets, we love compiled code, we love commandlets, but one of the benefits of advanced functions is that you have access to the source code, right? You have access to the script. And so when you think about sharing that with somebody else, it's a real benefit because then they can see it, they could modify it if they need to, and they can see exactly what's happening. And they might also learn something as well. So it's a key difference. When you think you're going to share something, it's a benefit there. It's
a huge benefit. I don't know if you guys know the scripting guy, Superstar Ed Wilson. Superstar Ed's in the audience here, and every year he runs the scripting games. And one is just a ton of fun. But the other benefit is you get to see how other people's scripts, and you learn a lot from that. So too, when you share your scripts and you take a look at somebody else's implementation, you learn a lot about how they do things. Also, when you share, like I've shared scripts, and people like in the audience here will say, well, why are you doing that? Why didn't you do it this way? And they'll teach you things you didn't know. So it's a huge benefit. So here's a traditional V1 script called getLogFile V1, and it takes a path and then 2 date times, changed after, changed before. It checks to see if the path exists and writes an error if it doesn't, and then it gets all the log files and pipes it to where they're within that time range. Okay, so this is a traditional V1 script, a pretty good script. Okay, so we'll import this, and then we'll show this running. Okay, now here we didn't specify the command name or the log file, or the path, so it issued an error message. And here we specify it, -path./logs, and it works. Okay, so that's just to set things up. So now we go, and this is exactly the same code with exactly one difference. We say commandlet binding. Okay, so exactly the same code, but we just add one thing, commandlet binding. I import that. Oh, by the way, sorry, 2 differences. It also says getLogFile AF, advanced function. Okay, so now I'm going to call the original script, and look, I'm going to give the parameters, the path, the start date, the end date, and then I've got this spurious argument. And what happens? Just works. Okay, really? So you give spurious arguments and it just works? Yep, baby, that's what informality looks like. So now I'll call the advanced function version of this, exactly the same signature, and it'll say, hey, wait a second, a positional parameter that you've given doesn't exist. Okay, so we do a level of error checking that's not available in regular functions. Okay, it also provides additional common parameters. So here I'm going to get command for v1, and I'm going to show the parameters. Okay, so you see the 3 parameters that we declare, right? Path, changed after, and changed before, right? But now I'll do this for the advanced function, and notice I get a whole lot more. This whole lot more are all the values of that PowerShell execution environment and the runtime engine. By just putting something commandlet after, you get things like verbose, debug, error action, warning action, error variable, warning variable, output buffer. We bring all that to you just by declaring commandlet variable. It's a good deal. Okay, next, we're going to make some of these parameters, oops, sorry, here we go. Now, keep the name the same, have commandlet binding, and we add this parameter attribute. So this parameter attribute now says, hey, this thing's mandatory, it can be positional, and it takes a value from the pipeline by property name. You'll see there's 2 ways to pipe things into PowerShell. One is by value, and the other is by property name. By value basically says, if something takes a process object, well then you have to pipe in a process object in order to match by value. Or what you can say is, I take a process name, something called name, and I accept it by property value. And that means I'll take anything. It can be a process object, can be a CSV, it can be anything. As long as it has a name, I will grab its name and I'll assign it here. So in this way, by putting something like this, PowerShell engine acts like an object shredder for you to bind you shred up the incoming objects, bind them to your function, and then execute your function. And then we've got some aliases. See, that's pretty simple to do, and some additional positional parameters. So we'll bring that in, and notice I invoke it, but don't give a path. I've said that it was mandatory, and so now PowerShell will say, hey, bucko, I need a path. I'm not going anywhere without a path. Okay, that works. And now here we use the pipelining. So notice we do dirs 8l star, that's log files, and remember this thing takes a string for path and it grabs it by value name. Okay, so what we do is, oh sorry, there you go. So I did the dir pipe to get log file. We took the name, bound it in, and we were able to execute it. Does that make sense? Cool. So you notice each step, what I'm showing you is each incremental step gives you more and more power. Notice I'm not dramatically rewriting the script each time.
By the way, that's one of the key things that you're going to see over and over and over that we do in PowerShell, is that in the engine we'll implement something, we'll take a lot of time, we'll spend a lot of resource to implement something, and then we'll ask you to do a small amount of work, and you get to take advantage of all that functionality that we built into PowerShell.
Yeah. So now this is what's called a parameter set. Okay? A parameter set basically says a command can take different sets of parameters. Just the same way you have net use, and that takes a set of parameters. You have net view with a different set of parameters. Those are called parameter sets. Okay? So this parameter set says, hey, I've got date and order. So basically, I've got two things, date, those were what we had before, we were doing everything by date, or order. It takes first and last. So let's get that in focus. I dot source that, and I can say get command minus syntax, and you'll see that there's two syntaxes here. This first one takes changed after and changed before, and the second one takes first and last. There are two parameter sets. Okay? Okay, so there it is, first and last. Okay, and now what I'm going to do is add some validation constraints. Oops. Okay, so here, validation constraints. Okay, so here, same script, and we added this. Validate range 2 to 10, validate range 2 to 10. And that says, hey, when you take in first and last, it has to be an integer, and it has to be between 2 and 10. Now, you go and you write, invoke this, and we'll try first 1, last 22. It says, no, it's got to be between 2 and 10. Now, at this point, a lot of people look at this and they say, yeah, okay, but really? Like, okay, so you just saved me 2 lines of code, right? Because I could have just as easily in my code said, hey, if first is not greater than 2 and less than 10, then print out an error message. And my message to you is, don't do it. Because if you write out if it only takes you 2 lines of code, and by the way, that's true, it only takes you 2 lines of code, you are writing an error message. And that error message will be, I guarantee, as many people as there are in this room, those are the different types of error messages users will get. Whereas when you use our attribute, there's exactly one error message. People will be able to see it, recognize it, and they won't even have to read it. They'll just be able to recognize it and go on. Next, I bet you, if you write those 2 lines of code, you're not going to translate it into French, German, Japanese, Arabic, etc. We do. When you use our attributes, we do all that work for you. So these attributes are really the way to go. Okay, and there it works. Lastly, we'll show you help. What am I doing here? Go away. Okay, so here what we've done, exact same file, but now we've put in help. Okay, this is comment-based help. By the way, if you have not figured it out yet, in PowerShell version 1, comments were a £sign in front of some stuff. In PowerShell version 2, that's still true, but we now have these block comments, which says, oh, I put that here, angle bracket, £sign, and then everything until I see this becomes a comment. So like, watch what happens if I do this. Plate. Right? All that just got commented out. Okay, obviously that's not what we want to do, so I'll put it back. So what you do is your block comment has to be in a well-defined place. Honestly, we didn't get this quite right, so I'll just say apologies there. It's a little too finicky about where the help comments have to be, okay? And it screws me up sometimes as well. So it has to be in the right place, and then you put things like .synopsis, .description, .example, .parameter, and again, you can provide a little bit of this, a lot of this, as much as you want to, okay? And then what happens is, when we .source it, now I can say get help, get log file, sorry, I did it with minus detailed. And look here, there's my synopsis. We generate the syntax for you. There's the description you gave, path, and all those things.
By the way, much easier to read in the comments than in the external help in the PS MAML file.
Exactly.
So again, if you're going to share
Lord.
it, it's just a lot easier to see.
Yeah, and I should point out, so part of the help is here, and then the other is these comments on the parameters. So like take first, we put a comment right in front of first, and then here, that comment gets extracted and put here. And it's full help. So what's full help? I mean the full enchilada. So you can say get help log file minus parameter path, and we'll give you the details on the individual parameters. So it's really quite rich. So the net of this is that in version 1 you had functions, which were very simple. They still exist, but they were kind of an informal way to do things. Now with version 2, you have a set of incremental changes that you can add to your scripts. Each of those incremental changes provides you a ton of value and makes your script more formal, just as formal as these commandlets written in .NET. Oh, I've got one more. Oh, good heavens, I got one more. I was finishing, and I should not have done that. This is the best. This is the bee's knees. So,
Better run it first.
How's that? Oh, did I run it?
Didn't open.
Didn't open.
Open it manually.
All right. Okay, so here on our commandlet binding, we have supports should process equals true. You want to pay attention to this one. This one's just the coolest thing. And here we're mocking up the fact that, that we're going to have a side effect on the system. In general, you just do it when you're going to somehow change the system and the system might be bad. Okay? And so then down here in process, remember there's this $ps commandlet, and it has a parameter or method called should process. You tell us what you're operating on and what you're going to do, and it's going to return true or false. And if it returns true, we perform the action, and if it returns false, we do nothing. Okay? So pretty cheap date. And with that, here's what you get. Get log file minus what if. Tells you what it would have done, but it didn't do it. Then we'll say minus confirm, and notice it tells us, so why do you want to do this, right? Here, notice it says, I'm going to do this to this name. So you now know what this dir actually translated to. Okay, translated to that file. Do you want to do that one? Yes. Do you want to do this one? Ooh, no. This one? No. You can always say suspend. Say, what things am I talking about? Oh, that was the only one that was interesting. Exit. Brings you back to this. Say no to all, and you're done. Okay, so that's advanced functions. Fun, fun, fun. Play with that.
All right. Another key feature of production scripting is modules. So I'm going to show you what modules are. I'm going to get rid of this. So all of you are familiar with scripts, I'm sure.
By the way, quick check. How many people are actively using modules, which is to say creating modules today? Okay, the rest of you should really pay attention. This is super important stuff.
So I want to show kind of what modules are, how they're different from scripts. So first of all, let's start with a script. Key thing to point out is that we made it really, really easy to go from writing scripts to writing modules. If you know how to write a script, then you pretty much know how to write a module. So in its simplest form, you can take any script that has one or more functions in it, and scripts have a .ps1 extension. Script modules just have a PSM1. So you can just change the extension, and now you've just created a script module out of that script.
Seriously, it's that cheap.
So let's take a look at a script that implements a simple counter. So I've got counter1 PS1 here. All this does is defines a couple variables, count and increment, initializes those. And it defines some functions, get count, is going to increment the counter and then return it. Reset count is going to reset our counter and set our incrementer. And set increment is going to set our increment.
And again, that was a PS1 file, not a module.
That was a PS1. So typically what we would do is we would dot source that so that we have access to those functions. So let's see what happened. If we do a git command, *count, you can see we have our get count and our reset count functions. Just what you would expect. So we can try it out. Get count. You can see it's counting. Then what about our increment function? Git command set increment. You can see that that's also available in our session. You can call it. You see we're incrementing by 7 now. And then what about those variables that we defined, count and increment? Are those available? Indeed, those are also in our session. So you can see that's the result of dot sourcing. Dot sourcing takes all the members that are defined in the script and brings them into the current context, into the caller's environment. And that works, but it leaks. So let me describe what I mean by that. All right, so let's take a look at how we can take our script and turn it into a module and what benefits that provides. So as I mentioned, we can just take that script and turn it into a module by changing the extension from PS1 to PSM1. So I'm going to do a copy item and change the extension there.
Did you describe leaking? Or are you going to do that?
I'm going to describe leaking, indeed. Yes, it's a key part of the demo.
Indeed.
Then it's really easy to import the module. You can just give it a path. You can call import module and give it a path to the module file. And we can see what got imported. So we can do a get command, use the module parameter, counter1, and we can see that, okay, we get those functions. We get our get count, reset count, and our set increment. But then what about the variables? Okay, this is interesting. This is a key difference between scripts and modules. So our variables aren't in our session. This gets to the default behavior for script modules is that by default we make all the functions public, but we keep variables and aliases private. That's because typically those are just going to be used internally by the script. And so we don't want those leaking out into the caller's, the global environment by default. And then we can use remove module to remove whatever was imported and clean it up, which is not possible when you dot source. Once you dot source, those members are there permanently in the session. You can't remove them. All right, so when you think about those three functions, really we don't want set increment to be public either. That should just be called by reset count.
Was that your explanation of leaking?
I'm getting there.
Okay.
That should be kept private to the module. So how do we do that? We can use the command like export module member. Within the script module, we can specify exactly what gets exported from the module. So let's take a look at our counter to script module here. Same thing as before, except now I've added a call to export module member here at the bottom. So I'm just going to export the count functions. So I can re-import the module. And now if I do get command count, you can see I have those available. But if I try to get command on set increment, that's not available. I can still call the get count function. And I can remove the module.
By the way, that's a key difference between modules and scripts, is you can remove modules and it just gets it out of your environment. Scripts, once you've dot sorted it, you got it for life.
Exactly. We can also interleave calls to export module member, and then we just add up all those calls. Each one operates independently. That can be kind of cumbersome because you have to remember, okay, I defined a function, now I have to call export module member. Let me show you a little trick as an alternative. So in this example, I'm defining a function called public. And what I'm doing is I'm taking three parameters, one of which is the type of the member that I want to make public, the name of the member, and the value for it. And then I just go through a series of if statements. If it's a function, I create the function with the value and name specified. Same thing with variable, same thing with alias. Okay? Now I can use public like a keyword. So for example, if I want to make the increment variable public,
That's awesome.
yeah, I can just say public variable increment, set the value. And then it's really easy when you're going back and you have to maintain the script. You can see, okay, this one's public, this one's private. For example, down here, I have set increment, that's not public, that's really easy to see now. And I don't have to worry about calling export module member, that gets abstracted away.
He wants it in PowerShell 3.
All right, we'll think about that. Now you can call
Wait, can I say, but that's a great comment. He said, oh, can you put that in PowerShell version 3? The answer is maybe, and we'll see. But what we tried to do with PowerShell version 2 was to make it open enough that you guys don't need to wait on us. Because, right, we take a long time. We're Windows, right, baby? And with Windows, when we release version 3, we know it's going to be used by upwards of 1 billion people, right, or 1 billion machines. So we go pretty methodically and carefully, et cetera, and we take a while to make sure it's cooked. But if you need it today, you want it today. So we went out of our way in version 2 to provide lots of things, make lots of things public, so you can get what you need without waiting for us, like Dan just showed you.
Yep. Thank you. So now we can import that. Do git command on our module, we can see that only those things that we made public are in our session state. We can call those things. We can call increment, which was a variable. Previously, in our earlier example, the variable wasn't available by default. And we can remove it. So a key thing to call out is that each module has its own session state, its own execution environment, and it doesn't pollute the caller or the global session state wherever you're importing it into. And in that way, it's very isolated so that it doesn't impact anything else running on the system.
You never explained leaking.
Well, that's what I'm saying.
Okay, so
doesn't leak.
Okay, yeah, but here's the point. In the original script, when he brought it in and you saw that the variables were shown, $count and increment, yeah? So what happens? So you write this great module, or great function, and it's got script and increment, count and increment, and I love it. I dot source, and oh, that's awesome. And then you have this other great function, and it has count and increment. And all of a sudden, I bring yours in, and you whacked over his stuff, and now you two are competing over the same name, and it's like, darn. And so that's why modules are so important for sharing. You can go write your stuff, use all the variables you want. You can write one that uses exactly the same variables, and then I can use both your stuff without them conflicting with one another. That's what leaking and the separation is, why it's so important. That's why we say modules are critical for sharing these artifacts.
Exactly. Think about how many people put $I in their script, or how many get user commandlets or get computer commandlets there are, get VM, right? It's a lot. So every module has its own session state, meaning its own place where it executes code and where it defines things. It doesn't stomp on anybody else. All right. Let's see. All right. So I've been showing script modules, which are the .psm1 files, but not all modules need to be written in script. You can also have binary modules. So let me show you how this works. The example I'm going to use is the Windows Automation Snap-in for PowerShell, the WASP project on CodePlex. This is one of the first projects. Goes back to PowerShell v1. And what WASP enables you to do is send keystrokes and mouse movements and keyboard events and things like that. So when you download WASP from CodePlex, you'll notice it has a few extra files. It has an install.ps1. So if you take a look at that, you can see that it does a bunch of stuff. It goes and it gets a path to install util, sets an alias to it, calls install util to register the assembly, it adds the snap-in, gets the commands, blah, 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 blah. And then there's also an uninstaller, which again removes the snap-in, gets a path to install util, sets the alias, has to uninstall the DLL to unregister it.
Blah, blah, blah.
Blah, blah, right. So even though the WASP commandlets were written as a .NET assembly, okay, and it was written before modules even existed, we can still load that as a binary module without having to change that DLL at all. So how does that work? And this gets to a key feature of modules, that they support very simple Xcopy deployment. You don't have to have any kind of installer or any registration like you had with snap-ins. You just copy the assembly to where you want it on the disk, and then you can call import module on it directly. So I'm going to call import module on it. You can see I'm going to use the verbose switch here and pass through so you can see what's happening. We just load the assembly, and then we go through and we scrape it for all the commandlets we find, and those get imported into the caller's session.
Isn't it another big difference that the installation requires admin privs, whereas this, exactly, you can just be regular user?
Yep. Depending on where you're installing it, you just have to have rights to put a file on disk.
Yeah.
Okay. And then we can remove it that way. So when you think about something like the WASP project, manipulating keyboard events and mouse events and things like that, probably not something you would use directly. Probably more likely that you would use that as a utility module to try and create a different type of solution. And this gets to another key feature of modules, which I'll show you now, which is nested modules. What nested modules allow you to do is take modules that have already been defined either by you or by the community or somebody else, and import those into a module that you're defining. And in that module, you can abstract the details of the imported nested module and craft a custom user experience for your user, for whatever the task is you're trying to accomplish. It's a really powerful concept. So let me show you a module that I want to use as a nested module. Okay, what this is, how many of you are familiar with James O'Neill's PS Hyper-V module on Codeplex? Have any of you downloaded that? Okay, so he has this super awesome module for dealing with VMs. And I downloaded that and I was looking through. It's a really big module, has a lot of great functionality, but it was a script and I wanted to turn it into a module. And down at the bottom, I noticed this comment that says, list functions added. They all have nouns that begin with VM or VHD. And I thought, aha, all I got to do is add a call to export module member and export the VM and VHD functions and give it a PSM1 extension. And now I've just turned his script into a nice script module that I can reuse. So then I decided to create my own module called VM deployment and use PS Hyper-V as a nested module. So one thing I noticed about PS Hyper-V is that it provides all this great functionality, commandlets and things to create a VHD, set the networking properties, all that stuff. But I wanted to play around with some VMs, and it was still pretty tedious to call all these different functions just to get a basic VM created. And I wanted to create lots of these things to play around with them and test them. And so what I decided to do was to create my own new VM function that would just blow out a bunch of defaults and create a default VM that I could play around with. And I'm using PS Hyper-V module to do that. So here I created this deployment script module. It has one function in it, new VM. Notice the nice inline help comments. And it takes a set of optional parameters, so I don't have to supply anything if I don't want to, but I can, do things like set the VM name, set the number of CPUs, memory, NICs, hard drive size, what kind of OS I want. And notice this key piece here. So I'm going to import the PS Hyper-V module into my VM deployment module, and then PS Hyper-V becomes a nested module of my module, and I can use it however I want. I can call those functions like set VM CPU count. I don't have to write that. I'm calling the PS Hyper-V to do that work for me. And then at the end, all I'm going to do is export a single function called new VM. So essentially, I've crafted this custom experience around, that's the thing I want to do, create a new VM, and I'm reusing something from the community to do that. So let's try it out. If I say import module, VM deployment, if I call get command on that module, notice I only have one commandlet, new VM. The other commandlets from the nested module aren't available. So it doesn't return anything.
Yeah, and this is key, right? Because in fact, that module had a ton of stuff. So again, if you're producing a tool for somebody else, you take a look at James' wonderful work, but you look at it and you say, ooh, that guy over there, he's not going to be able to get this. You know, it would be too confusing for him. So you go write a new VM. If he imports your module and then says, oh, show me everything I can do with the new VM, and he sees yours along with all of James and uses a ton of them, he's going to get confused. So you say, hey, hide all of James. I get to see it, but you don't. And all you get to see is my new commandlet. This is, again, a way you can produce artifacts for other people that simplify their job.
Right. So you can leverage the community efforts, build custom solutions with a user experience optimized for a specific task. Yeah. Exactly.
That is awesome.
All right. That's it for my demo. Switch it back over to Jeffrey to talk about universal automation environment.
Yeah, so this is basically the idea here is that, unlike other environments, PowerShell takes responsibility for executing your code. If you think about C# or VB, great things, but at the end of the day, they kind of view their job as, hey, they help you express your intent and get to an executable unit, and then, yay, they pat themselves on the back and go out and have a beer. For us, that's just the beginning of it, right? Oh, you've expressed your intent, now I have something that I can execute. That's the beginning of the task, because then we take responsibility for, hey, do I want to run it here, or do I want to run it there? Do I run it on there to one machine, or do I run it to 1,000 machines, or 10,000 machines, or 50,000 machines with a running throttle limit of 64, which is to say run 64 at a time. When one's done, bring another one in, etc. Do I want to run it with my current credentials? Do I want to run it with alternate credentials? Do I want to run it in an environment where I can do anything, or do I want to craft an environment where these are the only things you can do? These are the things we call the universal execution environment, and we support that in version 2. Right? So you'll see it's actually quite a vast, this is quite a vast vision. We think we have largely, but not completely, implemented it in version 2. Watch that space. We think this is super important. So how does that translate in terms of set of features? Kind of first and foremost is this notion of remoting, right? The ability to run code other places. We have background jobs, right? So sometimes when you want to run it, you want to wait and get the results immediately. Other times you want to run it and say, hey, I'll come back and get those results later. That's what jobs are about. Eventing. Sometimes you want to run it and get it immediately, and sometimes you want to say, hey, whenever this happens, run this. That's what eventing's about. Restricted sessions. Sometimes you want to run it in an environment where I can do anything, and other times you want to say, no, actually, this is an environment where all you can do are gets. Okay, so you can do inventory scripts, but you can't change the systems. And then we have this notion of the mobile object model, which is to say, when I go get an object from a remote machine, how do I get it in a way that I can continue to program against it and do a whole bunch of stuff, even though I don't have all those things? So for instance, I'm on this machine and I go and I get Exchange. When I send the code over to my Exchange server, I can do anything I want. But when I take those Exchange objects and I bring them back here, well, obviously I don't have Exchange here. And so how do I continue to program against it in a way that I can do something, but not everything I could do over there? We call that the mobile object model. So we have 3 remoting scenarios. Okay? The first is fan out, which is to say I'm here and I'd like to perform an operation on lots of machines. Okay? And we got lots of support for that. This notion of throttling, you can select how many objects you want to come back, etc. The next is one-to-one secure telnet. I'm here and I want to interactively interact with that one machine. And then there's fan in, and this is really a developer scenario where you say, hey, I'd like to host PowerShell in an IIS application and have everybody in the world come to me. Okay, so this is best shown.
I want to open a new one.
With the right laptop. Which one? All right. Okay, so by the way, so remoting is turned off by default for security reasons, and what you do is you say enable PS remoting, and that'll turn it on. I've already got it turned on this machine, so I can just do things. So when you do something like get process star ss. Okay, when you do that, that is in fact shorthand for this. Okay, those two things are functionally equivalent. The difference is that invoke command has lots of other parameters. You can say minus computer name, which is say, hey, I'd like to run this, and instead of running it in my process, I'd like you to run it over on that machine over there. Do it to myself. Additionally, I can say, hey, that's great, but I want to run it with a different set of credentials. Okay, now I can do this and say output variable. Well, here I'll say $P equals. Okay, we get this, and $P pipe 2. By the way, notice, I don't know if you notice this, back here when I just run it in process, here's what I get. When I run it remotely, I have this new tag, PS computer name. And the point of that is, if I go perform some operation on a large number of machines and I get objects back, I always want to know where those objects came from so I don't get confused. Okay, so we always add where they came from. So here, I got those objects, $P, and if I pipe that to get member, you notice it has all the properties. Okay, notice the methods are gone, because I can't invoke the methods, but it is a deserialized system diagnostic process. Okay, so what that means is I can do things like $P pipe 2 format table ID process name company. Right, all that stuff continues to work. I can continue to program against this object. Really powerful stuff. Additionally, here's a script, get disk space, .ps1. What I can do is I can say invoke ICM, shorthand, minus computer name, dot, minus file path. Oh, actually, we'll do it this way. First, go back up here. Okay, so notice I said local host. In fact, some people we released this, and some people said, hey, that's great, but why don't you change invoke command so that I can specify like an LDAP query of the commands that are the computers that I'd like to do. And I said, that's great, you already have that function. They said, no, I looked in the help, it's not there. I said, that means you don't understand command substitution. Command substitution is the following. Command substitution says, at anywhere I am in a command prompt, I can put something in $parentheses, and whatever I put in there will be run first, and the results of that command will be input as parameters into this command. So let me prove it to you. I can say hostname.
You need dollar sign.
Which one?
Dollar sign.
No, I don't want that. What is that? Oh, yeah. Sorry. Name. Let's just say. Well, here, read host as prompt. I've got a teenager, so whenever you ask him something, he's like, what? So we'll model that. So here, we run, remember I said anything within the parentheses, we run first, and then we give that, we'll just say dot, and then we run that command with that. Alternatively, I could have said, get AD, blah, 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 and done something. I could have done something from SQL, looked this stuff up in a SQL database, or I could have said import, or I have servers.csv. You can put it in a file and just say cat that file. Okay? So anyway, where I wanted to go was invoke command minus file path, get minus computer name, dot local host Yeah? And so you can take that script and we transfer the script to those machines, execute it, and get the results back here. Yeah? Great. So there's a ton to remoting. Here what I've done was I created a connection, I ran the code, and I tore down the connection. That's great if you're only going to do one thing to something. If you're going to do something to lots of machines, like import csv.servers, okay? Like here I've got a CSV that has computer names, etc., and I can say new PS session, and what we do is we create a connection to those machines, equals get PS session. And then what I can do is I can say invoke command $s, get the PID, and you notice how fast that is, right? It just happens very, very quickly. It happens very quickly. Why? Because I have an existing connection. So when you're going to perform an operation over and over again, you want to use these connections. Okay? So there's a ton to do with remoting. Spend some time with that.
Cool. Awesome. So let's talk about jobs now. Let's switch back to the demo. Yeah, and in fact, if you want to learn more about remoting, you can type help remote. There's lots of help topics in here. We didn't get to cover everything, but there's lots of help in the help system.
Let me just give them a story. So last year at Tech Ed, we had some guy come up at the booth and he said, oh, thank you. Remoting just saves my butt every week. He says, like a couple weeks ago, his boss brought in staff and said, hey, we got to get this information. They had a ton of servers. We got to get this information from every single one of our servers. I don't care what it takes. I need it by the end of the week. Call home, tell your folks that you're not going to be home before this is done. You put in whatever overtime, just whatever it takes. I need it by the end of the week. And he said he left the meeting and he thought to himself, hey, wait a second. And he went back to his office and quickly crafted a PowerShell script using PowerShell remoting, and he got all that information in 10 minutes. He says, so what did I do? He says, I did what any sane person would do. I took the afternoon off. He says, I came in the morning, he gave my boss this Excel spreadsheet, and the guy thought I was a god. He says, thank you very much for remoting. It's wonderful. I just love that story.
That's awesome. Thank you. So let's talk about jobs now. Jobs are very helpful as well. So let's take a look at what job commandlets we have. We'll do get command noun job. We have things like get job, receive job, remove, start, stop, wait. And what jobs allow you to do is execute PowerShell code in the background, asynchronous from your current session. So let's try out this start job. Call start job, give it a name. Let's say we want to get all the hot fixes on a machine. So we're going to call this hotfix inventory. And we pass it a script block. This is the thing you want to execute in the job. And we'll call the get hotfix commandlet. Okay? So it returns this PS job object back to us. But notice we can't see that it's running. It's running in the background. And then we can use the get job commandlet. And let's go ahead and assign this to a variable, $jobs. And let's see what's in this. So we'll pipe it to format list. Okay, this is our PS jobs object. You can see that there's lots of stuff here. The state, whether it's completed or not, whether it has more data to receive back, where it's running, what command it's running, its ID, its name, etc. Let's take a look at this property called job state info. Okay, this tells us what the state of the job is, whether it's running or whether it's completed or whatnot. Okay, now we have another commandlet called receive job. So let's take a look at that. Run help on it. Receive job gets the results of Windows PowerShell background jobs in the current session. Sounds like what we might want to run in order to get the results from our job. So we can call receive job. Let's clear the screen here. We can call receive job, pass it our jobs, and now we get the results back from the script block that we passed to when we created the job. There's also a commandlet called wait job, and what this does is it will block the command prompt until the specified job is done and completed, and then that allows you to write a script that creates some jobs and then stop the script until those jobs are done before continuing and doing more processing.
Yeah, and you can specify, do I want to wait until they're all done, or are any of them done?
Right. And then remove job will clean it up and remove the jobs.
Oh man, you didn't show them my favorite. Are you going to show them keep?
No, I didn't show keep.
Show keep.
All right.
This is great.
All right, I'll try to show keep.
You just use it
down
with
here.
what you have here.
I can show it at the end. I'll show it at the end.
Okay. You're going to love keep. My favorite. I use keep all the time. Anybody use keep? Okay, great. These guys got it.
Okay, so now let's use our invoke command. Ooh.
I got a quick question. Does it leak? Does it leak? Does it leak between the current job? So there are multiple ways to run jobs. Each way you run a job has different semantics. The one he just showed, it's running in a separate command, in a separate process. So it's not affected at all. When you do invoke, if you do a PowerShell, a WMI commandlet, and you say -as job, that's happening in process. Some of the AD stuff happens in process, etc. But when you say start job, we actually execute it in a separate process. But it's an interesting thing to point. There are lots of different ways to start jobs, but all jobs you interact with the same way. Receive, wait,
Right.
stop.
So you get a consistent experience in terms of managing jobs. You might start them in different ways, but when you go to manage the job, receive it, remove it, etc., you have a consistent experience. Okay, so I want to show that you can also run jobs against multiple machines. So here I've just created a new session against 2 computers. They're both local host. And now I can use my invoke command, which Jeffrey just showed, pass it this $S, which has my sessions, the script block I want to run, and now I say -as job. So it's going to run those as background job on each of those machines. And then I can give it a job name. Let's call this remote hotfix inventory. Okay? So notice I get one job back. So let's go and look at that a little bit more. Assign it to $jobs. And then you notice that we have this property called child jobs. So what we've done is we have one parent job, and for each job that's running on each machine, we have a child job attached to it.
Yeah, did you notice when he ran the first job, its ID was 1, and when you ran the second job, its ID was 3. What happened to 2? And the answer is, that's the child job. So here, the overall parent job is 3, and you have 2 children jobs, 4 and 5.
Right, and then you can receive job either on the parent job and get all the results back, or you can go in and receive job on each of the child jobs.
Here's where you
if
got to do
want.
keep.
All right, so I'll do keep.
Yeah.
So what keep does, by default, when you run receive job, it takes the results out and they're no longer in the job anymore. But if you say -keep, allows you to look at what's going on in the job, but still keep the results in the job object so you can retrieve them again later. So here's our output from our get hotfix. And
Just do it again. Do keep. Yeah, just
see, it's still there.
It's all there.
But if I don't do -keep, I get it, and now it doesn't matter if I run it again, that output I've now received that output and it's no longer in the job object. And I can get the output separately from the other child object. And I can clean up just piping get job to remove job. I'll use the force parameter here. All right, so that's jobs.
Great.
That's our last demo.
It is. So the question was, does each job run as a separate thread? And again, that's back to for the child jobs. Again, that's actually back to the implementation of the jobs. So you have WMI's implementation, AD's implementations, etc. In this implementation, yes, it's all running they're running on remote machines. It's actually not separate threads. We've got an asynchronous receiver. So we got a ton of new commandlets. V2 is just a big monster release. We got a ton of new partners. You will see more and more commandlets coming down the pipe. We got a ton of great community resources here. We got a ton of related content at this session. And track resources. We do want you to fill out those evaluation forms. We really do read every single one of those evaluation forms. We really appreciate your feedback. My only request of you is that if you decide to fill one out, just pay attention as to whether one is great or one is horrible, because sometimes we've gotten these best session and then it's like a 0 or whatever, the negative scale. So just pay attention to that. Sometimes they move it around. But have a great Tech Ed. Thank you very much for coming, and enjoy the show.
Thanks, everyone.
We have some